Playwright's Code. And tonight we're going to look at a little different subject. We have just a slightly different kind of show than we normally have. I'm working on a continuous integration and continuous deployment setup for our Wolverine Flasher tonight. And what I want to do with our Wolverine Flasher now is show you how you can set it up so that every time you submit a pull request, or you confirm a pull request, or you commit anything to your master branch, that you're going to get an automatic build for that. And you're going to be able to verify that everything that's been submitted is what you're looking for. And everything's correct. So with that said, we've made a couple of changes from last week. Up until now, we've been running with a repository on GitHub, but in preparing for this week's episode, I took a look at a lot of different options for continuous integration servers, and GitHub recently announced their actions, but what I've learned is that their actions really aren't ready for us to use for a C project, an embedded C project. I couldn't get their default actions that they had set up to run for a C project, and so I've moved this over to GitHub, or GitLab, excuse me, and you'll see the new URL at the top of the screen here. And using GitLab, we're going to set up a continuous integration process. So if you haven't looked at that before, this is what my repository looks like over on GitLab. And if we go take a quick little tour here, you'll notice we have the CI/CD lab, and we have pipelines. Now, in fact, if I go in here, there's a pipeline already created, and we've been running them. And lots of failed builds there, and we're going to see more failed builds tonight because, well, we're all looking for a successful build at the end of the day in our production. The value in a CI/CD pipeline is when it shows us where we have failed. And so we're just going to take a look. We're going to take a look at the different failure modes and how you can use those to make your project better and to get yourself to those nice green builds, like these green past builds down here. So a CI/CD pipeline always starts with some sort of configuration file. There are CI/CD pipelines that use more of a GUI approach. That style has fallen out of favor, and I've used that in the past, and I've used these configuration files, these nearly always YAML files. The YAML file is much better. It's a file that lives in my repository, and as the structure of my repository changes, my build pipeline is updated to match it, and so I'm always at a point where I can build. That's not really true when we're dealing with the more GUI style that my pipeline doesn't match, or my pipeline doesn't live with my repository. And I see I've got one person out there joining us already, so that's great. Bring your friends. It's a small audience sort of thing, so the more friends we can have here, the better. If you have any questions as we're going through this, please feel free to put them in the chat or any comments. There's bound to be more people out there with more CI/CD experience than I have, so let's take advantage of that. And so here's our this is just sort of a baseline for what I want from my CI/CD pipeline. And so with GitLab and also with GitHub and even to some extent something like Azure DevOps, a really nice professional package, we start with figuring out which Docker image we want to start from. And because we are a C and C++ project, it works out easiest for us to start with GCC as our base image. So that will get us all of our build tools that we expect to have to do a basic C build, and that will let us do something simple like run our unit tests, which is all to the good. So obviously we need to do more than just run GCC for Linux. So GitLab has a concept called the before script, and these are just items that get run before anything else happens here. Think of them as run steps at the end of a Docker file. So we need to update our package repository, so apt update. -QQ keeps it from prompting us for a lot of things. It just works automatically. If that succeeds, and only if that succeeds, we move on to apt install. We put a -y here so that it doesn't query us for whether we should continue with an install or not. If you forget to push this -y here, the first time you go to build, you will not get you won't get an image started up, which isn't a lot of fun. Now, if you were here for our first episode, everything that I'm putting here is just dependencies that we had to install to get ourselves up and working with GCC and the Arduino platform. So we need the GCC AVR compiler. We need libc that comes with for AVR. We need the Bing utils for AVR. That's going to have all of our components. They're going to take our compiled binary objects and turn them into finished objects that can be uploaded to our device. And because we're using a CMake based build, we really, really need to add CMake here. See, we've got a few GCC fans out there. I'll expect the CLang fans to show up later. So if I just submit this right now, it'll build an image for me. It's not going to actually build anything, but well, let's give that a go. Let me open up a terminal here. I had closed my terminal. All right, so you can see we've got one file out there that has changed. Let's ignore that chiron.txt file, and actually, let's try something. After the end of the last episode, Butch Howard showed me what was one of the neater features inside of Visual Studio Code. That's this version control window over here. This lets me have a graphical view of what's changed. Now, I had a working and frankly overly complex file running before, and we won't go into those. And I'm sorry if for some reason my color comes out a little weird in the stream. This actually has the normal green and red that you normally see inside of a diff window, but we'll solve that problem another day. So we can see here we've just got these things. That's what I want to check in, so let's put that there. So put a nice check-in message here, minimalist image information. Commit that, and we will push that. And let's go take a look at what's happening out here in my browser. So I just pushed that, and you just saw the screen update here. So it failed right out the gate. That's fine. We really expected that, but we see that's our message, minimalist image information. So let's go take a look and see what that job did. So okay, so we got a nice message, and this is one of the reasons that I absolutely fell in love with GitLab's CI/CD pipeline. When there is a problem, it gives you an error message. Not every CI/CD system will give you an error message. GitHub Actions in particular just tell you that it failed. It's literally a black box that says it failed. No more information is provided. I found that not helpful, and so I had to move the project off of GitHub, at least for purposes of our CI/CD pipeline. So, yeah, we're missing a job. That's great. We kind of knew we were missing a job. We did this intentionally a little bit rough. So, let's add a job. And jobs are really, really easy. Let's close this down. We don't care about that. We do care about our file here. So, a job is just an item in YAML in our file here. So we're going to make this really simple, the simplest possible job we can have. I have a script, and it's going to do a bunch of things, and through the magic of live streaming and my operating system's clipboard, we have now, oh, and I'm sorry, I was not gentle. Here's our new file. We realized I was showing you our browser. Here's the new file. So we added a job. So here's our item. Here is our script that belongs with that item. And this is a pretty familiar cycle that if you're used to working with GitLab or any CI/CD system and CMake, you're used to. And yes, Skylar, I am absolutely smitten with error messages. Error messages are my interface to the system, and I appreciate a good, helpful interface. So I'm just making a build folder, and I change into that build folder. Then I run CMake, and then make, and then make test. And this ampersand double ampersand between each step is really important. These ampersands tell the scripting engine that do not proceed to the next step unless the previous one has succeeded. Trust me that if you forget to do that, you will have broken tests and broken builds, but your CI/CD system, unless you designed your job particularly carefully, will not do the right thing. It will tell you that it passed, and you will commit broken code, and then all of your colleagues will wonder why their builds are broken. It will not be a good time. I did this to my repo at my day job yesterday, and it took us until the end of the day to figure out what I'd done. So we don't do that. All right, so this should be enough to get us something. This is going to run our tests. And for right now, that's, I think, enough to make us happy. So let's go back over here and take a look at our changes. So that's the only change we have. We added our script for testing. So we'll add that to our repository and tell it we added a job. And we will push. We'll switch back to our browser view and go to our pipelines. There's our job running. Look at that. We added a job. It's doing a thing. Let's go take a look at it do its thing. So there's our job. It's test. Let's go take a look at test. And it's building our Docker image. So I'm showing one example of a build system. There's lots of others out there. If you've got a hefty budget, Azure DevOps is a really good choice. They give you a lot of features and a lot of capabilities. I really like it. This is a great, GitLab is great if you have a smaller budget. But if you do have some budget, they have a lot of things that you can use. CircleCI has also worked really well for me. One of the advantages of CircleCI is it just works. Okay, so our job failed. So this isn't shocking. This is our main branch, and in fact, it's complaining that we don't have something called main. We have an undefined reference to main from the C runtime startup. from the start function, which is a little assembly routine inside of all GCC compile programs. So we have a failed build. This didn't fail because I wrote a bad CI/CD system. This failed because I wrote bad code. Now, in fact, the code that I wrote is missing something really important. It's missing a main function. So let's go take a look at what could be the root cause there. Now, in fact, in our test folder, this is our main. This is our main test. This is on our master branch. You'll notice the only dependency we have here for adding an executable is wolverine.c. And if you recall from previous visits, wolverine.c doesn't have a main function. In fact, here it's completely empty because this is the master branch, and this is just a starting point for what we would like to do. So what I want to do is go grab a main.c, or a test main, and we're going to grab the one that we've been using for the rest of our sessions here, just because it's going to be a little easier. And so let me just, again, through the magic of streaming and my operating system's clipboard, we're going to add a test main. And there's the body of our test main. And we'll go into our CMake lists. And we will also tell it about... Oh, in fact, it already knows about finding all the C source files here. Now, if we're going to be responsible programmers, of course, we are going to actually test our work. So we'll run CMake. I'll look at that. We built it. Make. Well, it didn't compile, so that's not so great. That's because I have forgotten really important things here. And I will tell you what those important things are in just a minute. Well, in fact, I forgot to tell everything about all the include folders. Turns out that all of your include folders are really important if you want a healthy build. So again, through the magic of my operating system's clipboard, we'll fix our CMake. We'll rerun CMake, rerun make. Yeah, it's a little grumbly. Indeed. So we're still missing something called test LED group runner. That's actually to be expected. We don't have any tests written because there's nothing to write tests around yet at this point. So let's make that. Still a little grumbly. And that's because we have not done the appropriate linking to our Unity library. So just a second, we're doing our best to use the magic of our operating system to add these sort of things in here. Now, we were good enough to add a dependency on Unity, but we weren't quite clever enough to actually tell it to use Unity. So target link directory says, hey, up in the there's a Unity directory, and you can find some of my dependencies up there. And target link library says actually link to the Unity library. And for those who don't remember, this last clause here says go build that Unity target before you try to do anything in here. So we yet again run CMake. We run make. And we have a build. That's excellent. Now, we also want to run test. We want a test target. So if I just type make test, do I get anything? No tests found. Okay. Well, that's actually to be expected because we didn't tell CMake about any tests. So let's go tell it about tests. And there's our test. CMake. Now make and make test. And look at that. We just ran our tests. So we had 0 tests failed. Of course, we aren't actually testing anything inside of our test. That's not the point. Or maybe it is, but this is enough to get us started to see if everything's working. So let's go back and have a look in our source control and see what's there. Okay, so the very first thing we need to do is we need to add, this is all the files that were made by running my CMake. So we're going to fix that little problem. We're going to add, at this very top level, we're going to add a gitignore. Tell it, hey, what's in build doesn't matter. And we're going to have another folder likely to come up called target build. We also don't want it to know about that. And frankly, I don't want it to know about that chiron.txt file. That never... that's something just for the streaming here. Oh, and I'm sorry. I've been doing all this stuff over here in code, and you have seen none of it. I've been showing you my browser, which nobody cares about. Okay. So this is where having live pair partners would be really helpful, because they would see me doing something silly and mock me mercilessly. Maybe next time. Maybe next time we'll have that. So anyway, here is my here's my gitignore file, and as you see over here now, I have a nice short list here of things that have changed. My test main, my CMake lists, and the gitignore itself. So I'm actually going to close that, and now we're going to add all of these items. So we added an actual test main. We commit it. We're going to push it. And we're going to switch back to our browser and see what we get. So of course we need to go back to our list of pipelines to find our running job. So there's our pipeline. It is running. There's the job. It is running. And we're building our Docker image again. Pardon me. This talking is thirsty work. And it's a Friday night, and I feel embarrassed for not drinking a cocktail, but if I'm going to speak coherently, it's probably better I don't. So I got a question out there, no Butch tonight. Indeed, no Butch tonight. I don't think Butch gets excited about watching somebody do CI/CD either. That would be Lily, who's one of my normal co-presenters, but right now she's just going to be an observer. She knows I'll make her strong pair through this because I want her to take over doing this at the day job. All right, and we have a build, and would you look at that? It succeeded. You see over here we've got a little indicator for a green test. Conveniently, that's actually green in the stream too. That's not always true. Our pipeline shows green, and if we go back to the pipelines view, we can see it's passed. Isn't that wonderful? That's exactly the kind of thing we like to have. So that is a bare minimum CI/CD pipeline, and for a personal project, that might actually be enough. You know, a lot of times I just want to know that I didn't break everything. But there's also going to be times, you know, maybe a more usual situation
is once I've committed the code, I really want to build a binary out of this. Building a binary makes the work available for everybody else. Either it could be customers, it could be fans of my project. Maybe somebody's looking for the downloadable image that they can grab for my holiday lights project, so that they can set up their own holiday lights and never have to take down Christmas lights again. Do a permanent Christmas light installation. But let's assume we want more. So I want to add another job to my CI/CD pipeline. So I've got my test here, and that's good. That's a great start. So let's add another one. I'm going to call this Avr Build. And my Avr Build is literally where I'm going to take my product. We're going to make it. We're going to build all the outputs that we normally expect. And I see I'm getting a note that my sound quality just diminished. Let me see if I can fix that at all. And we do not have the normal culprits are not present. So if anybody wants to click on if you click right on the video stream, should be a little option for reporting playback problems. Go ahead and let Twitch know that you're not happy with the playback quality. All right, and let me know if it gets worse. If you can't hear me at all, give a shout out. All right, so we're going to get our Avr build, and we had a. What did I put in my? Well, we're going to call the directory release. But we're going to go through roughly the same process that we had for our test. We're going to write a script, make a directory, we're going to call it release, and we're going to change to the release folder. And we're going to do a cmake, and if you recall from last week, we actually have we define a final flag. I mean, we're doing a final build of our artifact for our target. And that name should probably change at some point, but we're going to see what we do, okay? And, oh yeah, it's really important to do this. We actually have to make. Turns out to be super, super important to put that in the chain. And again, note the double ampersands between everything. Again, if you don't put them there, any of these steps could fail, but you would get a green pipeline, and that is a very bad scene. So some of my viewers got to fix that problem that I created today. So let's we'll save this, and we'll go over here to our version control, and we'll look, and we can see that indeed we just added that job. So job for the final build. We commit it. We push it. And let's go take a look over here in our browser. And conveniently, we already have it there, and you'll see that the new job just popped up. Pardon me, that's not the new job. Let's refresh the page. There we go. Oops, it had popped up and I refreshed at the wrong time. Okay, so our job is running. Let's go in and take a look at it. Our jobs are running. Now take a look at that. We have two jobs. We have the Avr build and we have the test build running. So we've seen the test build. And I guess we should go and look and we'll validate that, yep, it's running. So that's great. We'll go back out and let's go to the Avr build. And what's it doing? It's running as well. So let's watch it come to its logical conclusion here. And we'll see what it does. With any luck, it'll build. But do take note of the fact that it's building and the tests haven't completed yet. And in a production situation, I really don't want that to happen. I really want my my final object, my final binaries to be built after my tests are completed. Because if my tests fail, I generated a bad binary, and I don't want somebody to download that and install it. But you can see we ran here. We've got all the things we're looking for. We've got our ELF file, our map file, and our hex file, and our list file. It even knows which port to upload it to, although obviously that's not going to play well in this particular environment. This is on a GitLab server in the cloud, not on a local build agent that's hooked up to machines. And I'm not going to go that far tonight. I see Skylar's trying to get me to just go right out ahead there and just hook that up here. And I think in a future session that might be a really great thing to do, to really show continuous delivery for an embedded project. I haven't managed to do that for my day job project yet, so to do that for a personal project I think would be a really great goal to achieve. But we aren't there yet. We'll get there. We'll get there. And when we do, we will rule the world. Pardon me, wrong camera. Okay, you can see here we've got our progress images for all our builds. They're right there. And we actually built it, and we're getting a map of all the sections. So we had 188 bytes of text. The body of the functions are all empty. Really, there's nothing to be there. The 188 bytes is literally just the startup code. But, you know, we did actually generate our final binary. Now, if we go over here and look, we can see the details. You'll notice there's nothing uploading artifacts for a successful job. So, it doesn't say anything about where those artifacts are. Now, if we had created artifacts, we could click on this Avr build and it would take us to a list of the artifacts. So this is a great opportunity to go over to back to code, and we're going to go over here and we're going to tell it about artifacts. And GitLab will store artifacts for you, just like other tools will. Its artifact storing capabilities aren't that stellar. It's not what I would want to use if I wanted better control of my artifacts. In a situation where I needed to be able to retrieve artifacts from a specific build, or be able to always know that I was getting the latest, such as if I was a test engineer and wanted to validate that the latest build hadn't had any regressions, I'd probably use something like Artifactory or even just an S3 share with a good naming scheme for things. It would make it easier to find what I needed. So let's tell this about artifacts. And artifacts is just another item that goes in our job. And all of this is really well documented on the GitLab wiki about their CI/CD pipelines. So even if it seems like magic what I'm doing here, if you go and look on their wiki, they explain everything really well. They've got examples of how to do things. So we're just going to tell this to grab everything that matches a certain path spec. You can give it multiple items, so we only care about certain binary artifacts. But you might have to have test coverage reports. You might have to have test results. These are all things that you can capture and have treated as artifacts that exist with the job. Okay, so there's everything under the source folder, and that'll actually be source beneath the build folder, or the release folder in this case. And we're saying just keep digging down. Double star means through any number of directories until you get something matching this path spec. And all of our binaries, if you recall from our foray over into the browser, all of our binaries are listed here, and they start with Wolverine-AT-Mega 328P, and then just whatever suffix they happen to have. So we'll go back over here to code, and Now, I think this is ready to submit. So let's go take a look out here. This says all we added was the artifacts with the paths. So we'll add that. Tell it to save the artifacts. We commit it. We push it. We go back over to our browser. And we look, and our job is already running for us. Isn't that great? So there they're running. And again, the test build is running at the same time as the Avr build. We'll address that in a minute. Right now, let's just watch our Avr build, and let's see if we got a nice, if our artifacts get saved. Excellent. I've enlisted Skylar into my Save the Artifacts campaign. There'll be signatures collected for a ballot proposal this fall. Okay, we're doing our getting, we're doing our building. We did our building. We're running our after script, saving our cache. Error, no files to upload. Well, that's very unfortunate. Okay, let's see, if clicking there gives me any more information. It really doesn't. I'll tell you what, this is a really great opportunity to look at our local build tree, and let's just have a look and see what's really out there. So we're back here in code. We're in our build folder, and I'm sorry, our build folder. This is where our tests are built. Let's do a release build. All right. It says we're going to get those files there, and let's do a make. Hey, we did our make, and if I do my make that way, it will not work well. Let's try that. They're actually directly under source, and so when I told it to go look for folders, there were no deeper levels of folders to go get. So I said, hey, there's nothing to go down, nothing to descend there, so I can't match anything. So that's what our pattern looks like. That's on me for not remembering how CMake works, where it does its builds. Okay, and we forgot to add release to our .getIgnore, so let's fix that. We had thought we were going to call it target build, and we aren't. We're going to call it release because, well, we've already done it now, haven't we? Okay, and now if I go back and look at, this is much better. So we'll check. GetIgnore shows that all we really added was the release. And GitLab shows that what we did was remove the troublemaker from our artifact path. So these are both ready to be committed. We have to find the artifacts. In fact, we can feel a little bit like Indiana Jones. I'd pipe in the Raiders of the Lost Ark music, but well, they'd probably make me pay them, and also it would be cheesy. Okay, so we have pushed, and let's go take a look on our browser and see what's happening. All right, we're running again. Find the artifacts. That's our build, so that's a good sign. So yeah, just to clarify, Skylar, yeah, the double star means that there is at least one directory deep. It never collapses down to 0 directories. It's a sad state of affairs. They're going to make us poor developers understand the work we're actually doing. I don't approve of it, but it's the way we are. And I want a pony, too. Well, Mandar's got a flash from the past there. Go watch Pinky and the Brain take over the world. I'd be satisfied for taking over my living room. Okay, still no files to upload. Well, that's kind of sad. That's a lot sad. Alright. I'm not sure why it did that. And unfortunately, one of the disadvantages of this is I can't get a view of where my files really are. So, if I look back at what I did before, 18 mega through 28p, 18 mega, p.star. Alright, well. I guess I should check my build too and really make sure that the things got built like they said they would. It says it's generating Wolverine 18 mega 228p.lst and .hex. Okay, well, let's get more explicit in our paths. Let's put ** Wolverine 18 mega 328p, and that was foolish. I did that there. That's not helpful. Let's do it here. Now, fortunately, code is kind to us, and it actually did the right thing. So, ** Wolverine dash 18 mega 328p. Let's just check down here. That's fascinating. Didn't find anything. Oh, and that would be because I can't spell. Okay, so that pattern won't get us anything. So I'm going to simplify this just because I'm tired of getting shown up by my compiler, frankly, or my ignorance of how file globbing works. That's an interesting question, Mandar, and I didn't do it when I was trying it this weekend. It can't really hurt anything. Let's give it a shot. The worst that could happen... Well, let's try it as it is, as I just did it now. If that doesn't work, I'm going to try it your way, Mandar. We're just going to put quotes around it. There is a risk that it is somehow expanding in place, and that's messing me up. Anyway, we can see here we have made changes, and so we're going to commit that. And push that, and we're going to go look at our browser and see what happens. Oh, that died early and often. That was our last commit. Where are the artifacts? So let's go see how that failed. Oh, we have invalid YAML. Okay. Excuse me, my assistant joined me. She insists on sitting with me because she doesn't get enough attention, which is funny because she literally spends her day sleeping right next to me. And we're evicting her from the lab, from the office, the lair, the thing with Pinky and the Brain. All right, so it really looks like Mandar's right here. So, but this was a bacon saver. And one of the reasons I love GitLab, they have a CI Lint feature. So I can paste my CI file in, and it will tell me if I know what's going on. Yeah, there's a problem on line 13. So you were exactly right, Mandar. So let's just go back and wait on our CI/CD pipeline page, and we'll see what's coming up. You can see the signs of our ignominious failure. All right, and it's getting very helpful with adding extra quotes. I prefer it didn't do that. I'm sorry, I didn't show you what I was up to. Let me get back over and show you what's going on with code. So that's the change we made there. We'll go here, look at our changes, and you can see we've added quotes around it. Commit that. And I'm just going to take that code back to oh, okay. It won't let me do that. There we go. There's my linter. And we're just going to take our lovely YAML here, and we're going to paste it in. We're going to see, does it validate now? Okay, syntax is correct. That is great. Yeah, that's wonderful. That's what we wanted to see. So we're going to go back over, look at our pipelines, and okay, that's waiting there for us. I'm going to push our latest magnum opus, and we'll see. We'll wait for that to come up. And we'll wait. It'll be here in a minute. There we go. There it is. Please find the artifacts. It's running. It didn't fail out. That is a really promising sign. Definitely further ahead than our last build got us. And to answer your question, Skylar, it's valid YAML. It should be valid. It should be valid file globbing too. I did test that down in the terminal. We've got a minute here. I will show you what it looked like down in the terminal. Here's that expression there, and it found all of these files here, so that's good. And I'm going to take us back over to the browser now because I think the thing is happening. Okay, we aren't as far along as we were hoped I was, but we just built, so that's all to the good. And still no files to upload. That's just sad. I just did not like that. That's so sad. It's just not finding the artifacts to upload. Okay, I want to move on from that now. There's a deep rabbit hole here to dig down, but we've only got about 10 minutes. I've probably already stretched everybody's attention spans a little bit watching builds run. That is the exciting life of DevOps, is waiting for builds to run. As I'm sure Skylar knows well. So let's look at one of the other problems that we've noticed. I'll do a follow-up blog post or something, or maybe a short video about how to get your artifacts saved. It's guaranteed to be something stupid. So the situation that I don't like is, these passed, that was really great, very exciting, but these two run at the same time. And there's no reason why that has to be the case. And GitLab provides a really great capability for doing that, called stages. And so we can define all the stages that we want. The stage names are pretty open. For most projects, a test and build are sufficient. If we're actually going to get into continuous delivery, there's almost certainly a deploy stage, and probably then an acceptance test stage or an integration test stage. So we're going to define two stages that are test and build. And each job can be said to belong into a stage. And so we want the test to belong to the test stage. And maybe test is a great name, but let's be more specific. Let's call it unit tests. And just so we don't have confusion. And Avr Build belongs to the stage build. And with a little bit of correct typing, we'll get further here. And so the way GitLab works is... I am so sorry. Thank you, Skylar, for pointing that out. I did not show you my code. You're looking at my browser, which is boring. It's not so much that the screen share failed, it's that I forgot to actually tell it to show you the code browser. This might be where tools like GitLab's Web IDE would be better to use for something like this. So you're always looking at the browser, and we're doing our editing at the browser. But we weren't that clever. We didn't think this all the way through. That's a story of most of my career there. Alright, so let's review what I just told you. We've added stages. You can define your own. You can call them what you want. I'm calling mine test and build. And we have renamed the test job to unit tests. And that belongs to the test stage. And we've added Avr Build to the build stage. So we've done that. Let's go take a look at our changes. You can see we did a lot of exciting things. Added the stages, changed the test name, added jobs to stages. So I think that's good. We're going to commit it. And do the jobs in the right order with just a little bit of luck. And we have committed, and we will, you know what? So we don't have ugly incidents. We're going to go back over to the browser, and we're going to watch our job. We're going to watch the pipelines. So there's everything. It shows our last job is passed. That's great. I'm going to push now. And the push has happened. And if we come over here, we should see it come up just in a minute. There it is. It's running. Now let's take a look at how it's running. So you can see our display has changed. They aren't standing one on top of each other and running in parallel. The unit tests are running right now. And we've got a little round stop button. I'm gonna treat it as a stop button sitting over here on the Avr build, and that's not going to happen until our unit tests have completed. And normally, just to avoid that sensation of watching paint dry, I would go in and look at the unit test build, but I don't want to. I want to see that transition here. So it's running. Of course, it takes a couple of minutes for that to happen. So we'll just let that continue on. And it's going to continue to run. So, hey, that's a good question, Skylar. Why do jobs run in parallel by default? So, if jobs aren't assigned to a stage, oh, look at that! Our unit test just finished, and the Avr build has started. So, if jobs aren't assigned to a specific stage, there's a global unnamed stage that they belong to. And the rule is that every job that shares the same stage runs in parallel. And that's just so that builds can get sped up. If you've got a bunch of different, say you had to run a bunch of different types of unit tests, you could do all of those at the same time. Or maybe you have a bunch of silly little utilities that need to get built. Those all get built at the same time. so that they can get built and be included into the final package. Lots and lots of reasons to parallelize jobs. So by putting them all on the same stage, we make sure they all happen at once. And until every job in a stage is finished, we don't go on to the next stage. Then having that next stage lets us gate it. And now you'll notice our build has completed. Oh, isn't that wonderful? All right, we're coming up on time here. We've got about 4 minutes left by my watch. There's one more thing that can be really, really helpful. It's really cool to maybe we don't want to run tests on every commit. You send a lot of interim commits. It's really common actually to, end of the day, Butch talked about this a couple of episodes back. You push a broken test so that when you come back the next day or the next time you can come back to your project, what is it I'm supposed to be working on? You push that off in a feature branch somewhere. It's not in the main line. But if you're building on every single commit, you've turned your build red at that point, even though it's out on a branch. You've turned your build red. Everybody freaks out. It was 5 o'clock on a Friday and you're going on vacation. Everybody freaks out about your red build. You're getting calls at the airport. It's a bad scene. We don't want it. So, we can limit when those test builds get run. So they allow rules in here, and I'm going to show you the rule really quickly and we're going to go back here into code. I'm actually going to let you see the code, not just have to imagine it this time. So we can add rules. And what this rule says, and it's a little complicated, but there was an example. I don't know if you can hear that, but my assistant is back. She wants more lap time. So this rule returns true if the merge request target branch is master. And merge request is synonymous with pull request in other systems like GitHub or Azure DevOps. And if this rule is true, then we always apply this. Or I actually don't remember exactly why whens work. This is where I would encourage you to read the documentation. But this is from one of their examples, and I figured I will just use it. The really nice thing is this is completely configurable over here. So if you've got a development branch or a release candidate branch, you can have a different set of rules for each of those branches. You can be more stringent, require more tests, all kinds of good stuff. So we've added this, and so we're going to commit that, and run tests on the merge request, and I want to switch back over to my browser view. And we'll look at the pipelines to see what happens when I commit this. So do jobs in the right order. It's the last thing that's out there. We're going to push. And we're going to see what comes up. And in an ideal world, nothing. Nothing happens at all. Oh, it is running. Well, that's not what we wanted, but let's go see what it's running. It's not running the test. It's just making sure that our binary gets built. So we would probably want to change that up a little bit. We would add more rules. And make that behave better. You can add lots of rules that seem sort of a little bit duplicate, but do slightly different things. Um, there's a lot of power here, and I frankly haven't explored it all yet, but it's a thing that I do want to explore. But we do note that it didn't run the tests. We've set up something else down here to not run the builds. Doesn't matter right now. Let's create a pull request. So we're in our master branch here, and oops, I'm gonna switch back to code so you can see what I'm typing. We're gonna make a new branch. I'm just gonna call it feature branch or feature 1. I like feature 1. Oops. You know, if we put the rest of the commands in here, this helps. We're making a branch. We're calling it feature 1. And we're just going to do a little change here. And let's change something simple. Let's just add a section in here about a little plug for our CI service. We'll put that there, and I'm going to make Lily cringe a little bit by using -am. And we mentioned CI. We're going to push. Yeah, we're not going to paste what we wanted. Alright, sometimes you can switch operating systems all day but use the same tools. Sometimes you get bad ideas about what's going to work. Yeah, we're just going to type. Typing for the win. We have a new branch up there now. That's great. And if we go to the pipeline page, it's actually going to show that there's a build running because it's building the binary because we haven't got that sorted out yet. It is only running one job there. It says it's running. It doesn't really tell me which job it is. That's the Avr build. Isn't that great? You just click on it and it'll tell you which job it is. Now let's go over here and let's make a merge request. So we just pushed feature 1. Let's create a merge request. Oh, I've suffered a catastrophic ID10T error here, folks. Suffice to say, there was a build running for the Avr build because we haven't locked that out the way we really wanted to. But we're creating a merge request here. We want to tell the world about the wonders of CI/CD. And we haven't assigned anything, no labels. We're going to submit our merge request. And very good, we've got our merge request running. So in this here is saying, hey, we've got a detached merge request pipeline here that's running. And if we clicked into this, it would be a regular full, just be a run just like everything we've seen before. We'll just give this a couple of minutes here to run. Skylar, I feel like you might have a bias about wanting more CI/CD, almost like you set up DevOps tools for your day job. Okay, while we're just waiting for this paint to dry here, there's maybe some things to look at here. We have an option that we can turn on, and I haven't chosen it. We can tell this to just merge automatically when the pipeline succeeds. this is actually like pretty nice if you find yourself in a if you want to live in a world where we develop from master. So look at that. Our build succeeded here. So now we know, as a reviewer, I can come in here and know if I approve this code, it is safe to submit. It is safe, and I have a green merge button now. That's been enabled. So if I go ahead and merge that, it's now merged. I could do that, and I believe it has deleted the pipeline. I want to show you what happens with other pipelines. So this was a failed merge request from yesterday. If we go in here, you can see this failed, and this failed because we didn't have the test main written. And this is a failed build. Notice the disabled merge button. Now there's also merge conflicts because of course I've changed that file, but this was also gone yesterday. But the merge button goes away if whatever you defined in the CI/CD pipeline doesn't succeed. There is no merge button. You could probably even, if you got really creative, you could set up a rule somehow to look at people's calendars, and if you see that somebody's going to be out of the office next week and it's Friday at 5 o'clock, you don't let this go through. I have had in the past people push changes and then that broke the world and then immediately fled the country for 3 weeks. You might put a rule in like that. I'm not sure how you would script something up like that, but I'm sure a creative person could figure out a way. So let's, I kind of want to wrap this up, but let's go take a look out at our pipelines and see what just ran. There's our merge branch feature 1 into master, and it passed. Of course, we didn't run any tests. We only ran the Avr build because we need to build out that pipeline so that on master we also run a set of tests. It probably really, if we had continuous delivery set up here, we would also run master or run integration style tests where we really check how it's behaving on hardware when somebody merges to master, because of course that's the point where we want a much more comprehensive set of tests. So anyway, I'm gonna call that a wrap for tonight. If anybody has questions, feel free to stay in the chat and ask them. And otherwise, I'm going to sign